Welcome, everybody. We're leaving the best for last. My name is Tom Adamski. I'm a specialist solution architect focusing on networking across EMEA. I'm joined today by Karthik. He's the senior manager at EC2 networking team. And the session we have for you today is AWS VPN solutions. So I know it's the day after the big party. Might be easy to wander into the wrong room. So just to set the scene, this is a level 300 session, which means advanced. So we won't be going into basics like what is a VPC, what is a VPN. But we also won't be going very deep into the code and configuration. We're going to keep it at the architecture level. So we'll focus on tunnels, and we'll focus on the magic we can apply to those tunnels to build interesting architectures on AWS. And we have this session split into two halves. In the first half, I'm going to cover AWS site-to-site VPN. And you might know it as AWS Managed VPN. The name has now changed. And why would you use a site-to-site VPN? To connect to network environments, your data center to a VPC, for example. And then in the second half, Karthik is going to cover something we pre-announced earlier this week on Wednesday, AWS Client VPN. And a client VPN is where you have a remote user, maybe using a mobile device or a laptop connecting to a network environment like the VPC or other AWS services. All right, so let's start with a site-to-site VPN. Site-to-site VPN has been covered already a few times in the previous reInvents. So I wanted to focus here more on the things that I'm hearing from you, the customers, some of the frequently asked questions. Things like how much throughput I can get over a single VPN tunnel, or how can I combine multiple tunnels to get more bandwidth, or how do I make my setup highly available, or how do I optimize when things get too complex, or even how do I add network layer encryption to direct connect, or which side of the VPN connection actually initiates that connection. So site-to-site VPN. Effectively, it's a set of fully managed VPN termination endpoints on the AWS side. So we give you two VPN termination endpoints. So that means you'll have two tunnels per VPN connection. And we support standard protocol here, IPsec, AES 256 for encryption, SHA-2 for hashing, latest Diffie-Hellman groups for key exchange. We also support NAT traversal. So if you have NATing devices in the path, the VPN will still establish. And then finally, from a cost point of view, each VPN is charged at a per-hour rate. In most cases, this is 5 cents per hour. And we give you two setup options. So you can set up your VPN as a static VPN or as a dynamic VPN. And what's the difference? So a static VPN, from a configuration point of view, can either be policy-based or route-based, whereas the dynamic VPN is always going to be route-based. And the difference here is if you're setting up your device to be for a policy VPN, you're effectively defining the interesting traffic that should be encrypted to be sent to the other side. That's usually done for an access control list. Whereas with a route-based VPN, you're getting a logical interface that you can route traffic through. So anything going through that interface will effectively be encrypted. From a routing point of view, static VPN, static routing, dynamic VPN, dynamic routing. In this case, we're using Border Gateway Protocol, BGP, for the route exchange. And in both cases, we're using pre-shared keys for tunnel authentication. All right. So let's look at something that's common for both static and dynamic VPN before we start looking at the differences, and that's tunnel establishment. So we have here a VPC on the left in the 10.00/16 range, and we have a data center on the right, 192.168/16 range. I kind of push them to the side because we're focusing on the middle. And to set up a VPN, first thing we need to do is define the two sides of the connection. So on the AWS side, that will be the virtual or private gateway, VGW. And on the data center side, that will be the CGW, the customer gateway. And a customer gateway effectively is a firewall or a router, anything that supports IPsec and ideally BGP. So then when you want to connect those two things together over the VPN, we'll provision the set of managed VPN termination endpoints associated with the virtual private gateway. Those endpoints are deployed in different availability zones, and they're using public IP addresses from the AWS public address space. So then you can start establishing your VPN, but which side of the connection actually initiates the connection? And it always has to be the customer gateway. So if you configure your customer gateway to listen and wait for incoming tunnel connections, the tunnel will never come up. And then when that customer gateway initiates the connection, hits those two VPN termination endpoints, we'll look at a couple of things. We'll make sure that the pre-shared keys you configured are matching on both sides, and that the endpoint IP addresses on both sides are also matching. So if you misconfigured your customer gateway, it has the correct pre-shared key, but the wrong IP address, the tunnel will not establish. OK, so if everything is correct, our tunnels will come up. And with IPsec, we have a thing called security association. And that's effectively a definition of what traffic do you want to encrypt and how. And with our tunnels, you get 2 security associations per tunnel, 1 in each direction. So with 2 tunnels, altogether, we have 4 security associations. So let's start looking at some differences in specifics for the static VPN and dynamic. Let's start with the static VPN. So for a static VPN, if it's policy-based, you'll create your policy on your side. You create the ACL to decide what traffic you find interesting. And that will be the traffic going from the IP address range of the VPC to your data center and vice versa. And those rules, those policies, will effectively be mapped to the security associations that you have. So you will have a security association for the 10.00/16 going to 192.168.00/16. And then you'll have a security association in the other direction. And the same thing will happen for the other tunnel. So at this point, you can send traffic over the tunnel. You still have to configure your static routing on both sides, because this is a static VPN. But what if you have more than just a single IP address range on-premise that you want to encrypt? Let's say there's 172.16 as well. Normally, what you would do, you create another policy, specifying that range maybe in an access control list. And that would be mapped to another security association. But in this case, we've used all our security associations that we have available. So you have to change your policy to effectively catch any traffic going from on-premise to AWS. And then apply some access control list to limit the traffic that you don't want to see. Now, this is a static VPN, and it's good. But for most cases, you want to use dynamic VPN. It's much better at being able to react to any changes in your network environment. So let's have a look at dynamic VPN. So we know already it's route-based. So we'll have a set of tunnel endpoints on each side, tunnel interfaces. And you'll be able to specify the IP addresses for each side of the connection. They'll come from the 169.254 link local IP address range, but you'll be able to decide what they are. And then you'll also define each side of the BGP connection, specifying the autonomous system number, the ASN. So you'll have one tunnel, and then you'll have the other tunnel configured the same way. So now we have BGP established over those tunnels. The routes are exchanging, and you have 2 paths from on-premise to the VPC and 2 paths from the VPC to on-premise. So let's follow the traffic flow to see which paths are actually being used. So if you're sending traffic to AWS, you can override the defaults and allow for both tunnels to be used for sending traffic into AWS, into your VPC. However, in the other direction, the VGW will always pick one tunnel to send traffic back to you, even if it has 2 paths that are equal cost. And a single tunnel can support up to 1.5 gigabits a second of throughput. So right now, we have high availability in this scenario on the AWS side, on the VPC side. But we have no high availability on the data center side. If that customer gateway goes down, both of your tunnels are down. So let's add a second customer gateway. And let's create a second VPN. And for that, we'll have a second set of VPN termination endpoints, different IP addresses. And we can establish a second VPN tunnel with second VPN connection with 2 new VPN tunnels. So now we're highly available. But has this changed anything in terms of how we can forward traffic to and from AWS? No. So to AWS, we can still use multiple tunnels if we override the defaults. But in the other direction, even though we have 4 paths, the VGW will only select a single path for sending traffic back. OK. So a lot of customers don't have just a single VPC. Usually, you have multiple VPCs. So let's start adding additional VPCs to this scenario. So now we have a second VPC. So 2 VPCs. It's now 4 tunnels, 4 VPN connection, 8 tunnels. 4 VPCs. That's already 16 tunnels, 8 VPN connection. A lot of customers have built automation to deal with that number of VPN tunnels. But for some customers, this is a complexity they really don't want to deal with. So can we actually do anything to simplify and optimize that VPN setup? Right, so before we do that, before we look at optimization, let's analyze the setup we have from a cost point of view. And what cost dimensions do we need to consider in this particular scenario? So we charge for each VPN connection hour. And we have 8 VPN connections here, 16 tunnels, but 8 connections. And then we charge for the data out from your VPCs out to the internet. There's a data out at an internet rate charge. Data into AWS is free of charge over those VPN tunnels. So let's start optimizing. So what if we could move those customer gateways a little bit closer to where we have our VPCs? What if we could put those customer gateways in 2 different AZs inside a VPC? So now the traffic is actually staying inside the AWS environment. Right, so those tunnels no longer go all the way to on-premise. They stop in AWS on an EC2 instance. And then you could configure your own tunnels back to on-premise. So those devices in the middle, they could be your favorite routers, firewalls, running on EC2. And those tunnels back to on-premise, they're not AWS side-to-side VPNs. They're VPNs you built. And this is quite a known pattern. This is actually a transit VPC I'm showing you. And it's quite good in simplifying it a little bit, right? If we add a second data center now, all we need to do is build 2 additional tunnels instead of creating another set of 16 tunnels to all our VPCs. But what about cost? So let's split this into 3 pieces that will add up together. So on the left-hand side, we still have our VPN connection hours. We still have 8 VPN connections. But now something has changed. The traffic is no longer going out to the internet first. It's stopping at that middle VPC, at those EC2 instances. So it's a different charge, and now it's in both directions. That charge is usually around 1 cent per gig, but it's there. On the right-hand side, we still have data out going to the internet, so it's internet rate, data in, free of charge. We don't have a VPN cost here, because it's not a managed VPN. And then finally, last thing to consider is the cost of the underlying EC2 instances and any licensing you might need to deploy for that. OK, so can we make that even simpler? And yes, we can. This week, we announced the availability of the Transit Gateway. And the best way to think about a Transit Gateway is a distributed router managed by AWS that you deploy into a region. And we always show it as a single object. But the distributed here is the keyword. It's not a single point of failure. It's a distributed set of devices. So you deploy your Transit Gateway, the TGW. And then you create attachments from your VPCs to that TGW. And again, the attachment is a completely new construct. It's not a VPN. It's not peering. It's something completely new. It's another way for traffic to get in and out of your VPC through the Transit Gateway. So if you want, you can allow your VPCs to communicate to each other through the Transit Gateway. But then how do you connect that TGW back to on-premise? And this is a VPN talk. So you can probably figure out there's going to be a VPN involved. And again, we have 2 VPN termination endpoints. But this time, those endpoints are landing on the TGW. So we can establish our tunnels. We need a redundant tunnel to the second customer gateway. We have a second set of VPN termination endpoints associated with the TGW. And we build a second set of tunnels. But what's very interesting now is how this works with the traffic flow. So we can now use multiple tunnels to send traffic to the AWS environment. So using ECMP, equal cost multipath. But we now also can use multiple tunnels when we're sending traffic back to your data center. So this now allows you to aggregate multiple VPN tunnels to add more bandwidth while going back to your on-premise. A single tunnel is still 1.25 gigabits a second. That means a single flow will still be limited to that throughput. But you can now keep adding multiple tunnels together. What about costs? So from a cost dimension, we split it into two halves. On the right-hand side, we have still VPN connection hour, but we have two VPN connections. And we can have thousands of VPCs connected to this transit gateway. And then data out, still at internet rate. Data in, free of charge. On the left-hand side, we have a charge per transit gateway attachment. So that's an hourly charge. And then we have a data processing charge for the transferred data. That's actually very close to the VPC peering cost. So you're looking at this, you're probably thinking, this is great, but I already have a transit VPC deployed. How do I move away from the transit VPC to the transit gateway? So we'll go through that right now. So here we have three VPCs on the left using the VGWs to connect to those routers in the transit VPC, and then you have your own VPN tunnels going back to on-premise. And we want to get away from that and start using the transit gateway. So let's first of all create the transit gateway, TGW, build our attachments. And you see the attachments are separate to the VGW. They don't connect to the VGW. They connect straight to the VPC. And from a routing point of view, you'll have a route in the VPC routing table that at this moment is sending traffic to the VGW. So maybe it's a default and default pointing to the VGW. So nothing's changed. You have your TGW attached, but you're not sending traffic through it. The next step you want to do is explicitly set the preference for the top path so it's always preferred. Because straight after that, we're going to create those VPN tunnels from the TGW going back to your on-premise device. And at this point, we want to make sure the traffic is still going over the top path. Right? So this is our preferred path, but the TGW is now connected on both sides. It has attachments to the VPCs, and it has AWS site-to-site VPNs to your on-premise data center. So now if you don't have any stateful devices in the path, like firewalls or nothing devices, you can actually have the traffic asymmetric. So you could start with your data center side and just send traffic over the TGW to your VPCs, but your VPCs are returning the traffic over the transit VPC. And then slowly start changing the routing table inside each VPC to point from the VGW to the TGW. You do that in all your VPCs, and if everything is working as expected, you can scrap the transit VPC. Happy days. OK. So far, we talked about the VPN in the context of it going over the internet. So we're going back to our VPC. That VPC actually lives inside the region. That region has an internet connection, and VPN tunnels that we talked about earlier are actually going over that internet connection. So we know internet can sometimes be unpredictable. So if we want to get more consistent and predictable experience, we can get Direct Connect. So Direct Connect is the private dedicated connectivity to AWS through a Direct Connect location, and effectively you get connectivity to the AWS backbone and to the region you want to go to. And on that Direct Connect connection, you can start creating logical interfaces, VLANs on your side, VIFs, or virtual interfaces on our side. And there's two types of those interfaces. There's a private interface that gets you into the private VPC environment, but there's also this public interface, public VIF. And that public VIF gets you to all of the AWS public IP address space, everything outside of the VPC. So that includes S3, DynamoDB, but it also includes those public VPN termination endpoints. So as soon as your device starts seeing the route to those VPN termination endpoints through the public VIF, those tunnels will actually automatically move over to your Direct Connect connection. So now you've added network layering encryption to your Direct Connect connection. And if we look at that from a cost point of view, you still have your VPN connection hour. The big difference here is the data out is now at the Direct Connect rate, which is usually multiple times less than the internet rate. And then finally, data in is still at $0. Last thing you need to consider is the cost of the Direct Connect port. OK, so this is for the VPC. You're probably thinking, can the same be done for the transit gateway? And the answer is yes. So this is one way for you to integrate Direct Connect using the VPN with your transit gateway. We already announced that next year we're planning to provide a native integration, but until then, this is one way for doing it. OK, so let's recap. We went through a lot. And hopefully, you answered all your questions. So you know the throughput of each VPN. You know that you can combine those VPNs together using the transit gateway. You know how to make your setup highly available. You know how to optimize it. And you know now which side of the VPN connection actually initiates the connection, and that's the TGW. That's the customer gateway. So now I'm going to hand off to Karthik to tell us about the AWS Client VPN. Cheers.
Hi. So I'm going to be talking about Client VPN, and what you'll see me do is I'm going to slowly build on the feature set. So if you find yourself, hey, how does this work? How does that work? Hold off on your questions. Hopefully, by the end of the session, I should have answered all your questions. If you still have any unanswered questions, we'll be available after the talk. Right, let's see. So just a quick recap. What's the solutions we have today for VPN? Natively in AWS, what we have what's called as an AWS Managed VPN. And like Tom mentioned, soon you'll see this name being changed to AWS Site-to-Site VPN. And moving forward, what we announced earlier this week was an AWS Client VPN, which will be launching soon. So this completes our VPN portfolio along with Site-to-Site VPN. We also have a Client VPN. So what's an AWS Client VPN? It's a fully managed client-based VPN service. With AWS Client VPN, you can now securely access resources in AWS, being VPCs, S3, DynamoDB, as well as access resources on your on-premise. And you can do this from any location using any device that is running an open VPN-based client. AWS Client VPN also seamlessly integrates with your existing infrastructure, like VPC or directory services. For the rest of the session, I'm going to split this into 3 parts. First, I'll talk about the architecture about the service, and then I'll dive into details on the features, and then I'll finally talk about how do you set up the service. So we'll go into more of the details on setting up the service. So let's first look at the architecture. So there are a few points I want to call out here. The first and the most important is a client VPN endpoint. What is this client VPN endpoint? This is the resource that you are going to configure for the service. Right? This is a regional construct, right? And the client VPN endpoint is where all your VPN sessions are going to terminate. Right? And this is the resource that you're going to use to actually manage and monitor your VPN sessions. The second concept is a target network or your network. At launch, your target network is basically a subnet in a VPC. And what you're going to be doing is you're going to associate a subnet from a VPC to the client VPN endpoint. You can associate multiple subnets to a client VPN endpoint. The only requirement there is every subnet that you're associating has to belong to a different availability zone. You cannot associate multiple subnets from the same availability zone to an endpoint. But you can associate multiple subnets that belong to different availability zones. So you're basically limited on the number of availability zones that you have in a region. And the reason with this ability to associate multiple subnets, you get AZ redundancy. Another aspect here as well is the subnets that you're associating to a client VPN endpoint have to belong to the same VPC. So you cannot associate subnets from different VPCs to a client VPN endpoint. And finally, another restriction you have is from an account standpoint, your client VPN endpoint as well as the VPC, they have to belong to the same account. One of the things that I mentioned earlier was like when I was talking about what is the service is you can now, I said you can access any resource. And what I meant by that is, so now you're going to have different networks that are connected to this VPC, where you have a subnet that's associated to a client VPN endpoint. You can actually, through this single VPN tunnel, you can actually access all of those networks. Like you could have another VPC in the same region or a different region that's peer to the VPC. You can access that as well. You can get to your on-prem via VGW, be it a VPN connection or a direct connect. You can get to that as well through through a single tunnel. As well as you can get to S3 via S3 endpoints, as well as if you want to go to the internet via IGW, you can do all of that. So essentially, so long as your VPC has access to the other networks, you can actually get to that. And later in the session, we'll actually talk about how that's possible. And the last part from an architecture standpoint is the user, right? So I mentioned you can set up these sessions using any device that has an open VPN client. Right, so that's the aspect of the user. So the client that you're going to use is an open VPN client. right? So your users are going to connect to this client VPN endpoint, right? And your VPN sessions, which is a TLS session, so that terminates at the client VPN endpoint, and then you have your traffic flowing from your client VPN endpoint to this VPC, if that's your target, your destination network, and on to the other network, so long as it's connected to that VPC. So this is the architecture of the service. Let's get into the details in terms of features. Because your sessions are coming into this client VPN endpoint, so this is the first point of entry into AWS. So this is effectively an edge service, right? If you're an edge service, there are two features that I have to offer that's mandatory: authentication and authorization, right? So let's first look at authentication. For authentication, we support, at launch, we're going to support two types of authentication. One is Active Directory. And the way we're supporting Active Directory is we integrate with directory services. Right? So your Active Directory could reside anywhere. It could be in AWS. It could be in your on-premise. It could be anywhere on the internet. Doesn't matter. All you're required to do is you have to configure a connector in AWS Directory Services to ensure that you have access to your Active Directory. And what we do is we connect to that connector. So the advantage with this is you do not have to change your existing infrastructure. You continue to use the same Active Directory, the same infrastructure that you have, and we will automatically connect to that infrastructure. So that's with Active Directory. And another question that comes up is, hey, do you support multi-factor MFA? Right? So the way we support MFA will be through Active Directory. If Active Directory has support for MFA, then you automatically get support for MFA. The second type of authentication we support is mutual auth or client certificate. So the idea of client certificate is like, so now when your users, if you don't want to use Active Directory, but if you want to authenticate your users, you can use certificate-based authentication. And the way we work for client certificates is you will upload your certificate information to ACM, AWS Certificate Manager, and you will provide us the ON for that certificate, and then we will use that information for the authentication purpose. That's authentication. The second aspect is authorization. So the one thing which I want you guys to understand with authentication and authorization is, so the way I think of this is it's like two walls. So you have your endpoint. When your users are trying to connect, the first wall they're going to hit is authentication. I'm going to check, hey, are you allowed, are you who you say you are, right? So if I can authenticate you, then I allow you to establish that VPN session to the client VPN endpoint. Your session terminates, and now you're trying to access a network in a VPC or on-prem. You're going to have your second wall hit there, which is your authorization. After I've authenticated you, the second check I'm going to do is, do you have access to the network that you're trying to access? Right? That's where the authorization kicks in. So for authorization, we have two types of authorization capabilities. The first one is network-based authorization. The way network-based authorization works is you're going to configure for a given network which group of users have access to that network. So let me pick an example. So in this case, you have this VPC. So you're going to say, for this VPC, let's say site.1/16, I'll have group 1. And in this particular case, since we've integrated with Active Directory, so the group information that we're using is Active Directory groups. So you'll say, hey, for network 10.1, AD group 1 has access. And then so you can start configuring it by each network. We'll go into more details later in the session. So the idea here with this is like now you're going to control access by network, and you can specify. And if you want to open it up for the network, then to the internet, you just say 0/0, and then you specify which groups has access to the internet. The second type of authorization is security groups, because you're dealing with VPCs. Most of you probably have a security group configured. Right? So we will automatically integrate with security groups. And the security group that we would be applying is for that association between your client VPN endpoint and that VPC. Right at that link is where we're going to apply a security group. The next feature is connectivity. So one of the things which I mentioned earlier was with client VPN, you can access any resource from any location. Right? So when you talk about your end user could be located anywhere. They could be at home, they could be traveling, they could be in a conference like this, or they could also be in your on-premise. Doesn't matter. Right? So they're going to connect to your client VPN endpoint. And from a connectivity standpoint, using a single tunnel that they establish, they can access any resource. Right? Be it the VPC that was associated or the other set of VPCs that are peer to the VPC or on-prem or internet or other AWS services. They can access any resource. And a couple of other points from a connectivity standpoint is the tunnel that we establish from your end user to the client VPN is a full tunnel, meaning we're going to have a default route on the end user's device that will automatically send the traffic, every traffic, through the tunnel interface that's there on the device to the endpoint. Right? Couple of other things is the VPN connection between your end user and the client VPN endpoint. From a transport protocol perspective, you could either choose TCP or UDP. Typically, we've seen better performances with UDP compared to TCP. The challenge that TCP has is here when you go TCP within TCP, you get exponential backoff. So we've seen lower performances with TCP compared to UDP. And finally, from a connectivity standpoint, we're supporting IPv4. Two other features. From a manageability standpoint, this is a security service. So forensics is super critical for any security service. Right? So one of the very basic questions you're going to ask is, hey, who tried to connect to the service? Right? Was it successful? Did it fail? If it failed, why did it fail? When was this connection terminated? All of that information, all of the connection information is going to be logged. It gets accumulated, and then we're going to post it to CloudWatch logs. So you can specify which CloudWatch log groups and streams you want, and we'll post this every 15 minutes to CloudWatch logs. The second aspect of, from a manageability standpoint, is the ability to manage active connections. So there are two capabilities that we provide. One is your ability to describe and see what are all the active connections at a given point of time. A second aspect is you will also be able to terminate any given active connections. You could pick a particular connection, you can terminate that, or you could say, hey, for this user foo, I want to go terminate all connections pertaining to this user. You can do that as well. Right? So we give you the ability to actually manage active connections. And finally, from a client standpoint, like I mentioned before, so we're going to support OpenVPN-based clients. So it's not an Amazon-owned client, so you can just go pick any OpenVPN-based client and then run it on the device, and you should be able to connect to the endpoint. So those are the features. So now let's get into the more fun part in terms of how do you actually set up the service. So the first step you're going to do is you're going to create this client VPN endpoint. So what goes on with creating a client VPN endpoint? There are a few parameters that you're going to configure. The first one is the client CIDR. When users connect to this client VPN endpoint, we're going to be assigning IPv4 addresses to these users. Right? Where do I pick up this address from? That you're going to give us the client CIDR range. So we're going to pick up addresses from that client CIDR range. The second aspect you're going to configure is server certificates. Right? We talked about client certificates and how we integrate with ACMs. With client certificates, I'm authenticating the user. With server certificates, you are authenticating me, right? Because you want to make sure, as a user, when you're connecting, you're actually connecting to AWS, and you're not connecting to somebody else posing as AWS, right? And that's what the server certificate provides for you. With server certificates, again, we will integrate with ACM. You provide us the on. So you upload the cert information in ACM, and then we'll just take the on from ACM. The third part is authentication information. Like we talked about, you can either pick Active Directory or mutual authentication, or you could pick both. If you pick one or the other or both, you have to have at least one authentication mechanism configured. If it's Active Directory, then you're going to specify the directory ID. If it's mutual auth, you're going to specify the on for the client certificate information. The fourth one is connection logs. One of the things that we're going to make you do when you create the endpoint is we will mandatorily make you choose, do you want connection logs or not? The reason we're going to we're making it mandatory is forensics is a very critical thing in a security service, right? What we don't want to happen is, let's say you realized, hey, there's a malicious user. Let me go and try to find out who is this user, when did they log in, and then you realize, oh, there's no connection logs. Right? So we don't want that to happen. So we want you to make that conscious decision, do I want logging or not? Right? So that's the reason why we'll actually see this as a mandatory field that you have to enter. The fifth one is DNS server. Right? You have to specify what DNS server you want us to configure. You could typically pick the .2 address of the VPC that you're associating, or you could pick any DNS server. You configure that IP address. The next one is what is the transport protocol you want? Do you want TCP? Do you want UDP? You'll get to pick that as well. So once you've configured all of this, what happens is your endpoint status gets into a pending associate, which basically means you're still not ready to accept connections. But a couple of things that also happens once you've configured this is you're going to get an endpoint ID, and also you're going to get a DNS name. Right? This is the DNS name that you're actually going to use, that your users are going to use to connect to this endpoint. And also, you'll be able to download an OVPN file, an OpenVPN config file, and this is the file that you will actually provide to these devices that you'll upload to the devices, and this is what many of the OpenVPN clients use to connect. And if you look at this file, it basically has there are some VPN connection parameters. Then there's also the most important thing is it'll actually have that DNS name that was generated when you created a client VPN endpoint. And your DNS name is typically going to have your client VPN endpoint ID. It's going to have the region name, and then you'll have your aws.amazon.com. So like I mentioned, you still can create a connection, right? A VPN session. To establish the VPN session, it's step 2 is now you have to associate a client VPN endpoint to your network or your target network. As I mentioned before, this is basically a subnet in your VPC. So how you do this is you associate the subnet to this client VPN endpoint. When you do this, we automatically apply the security group, the default security group of that VPC to this connection. So if you don't want that security group, you always can go and change it. But if you don't want to change it, if you're happy with the default security group, you can use it. It's automatically done for you. Once you do this, a couple of things happen. One is your endpoint status becomes available, so you can actually now establish VPN sessions. Another concept that we have not talked about so far is route tables. Every client VPN endpoint has its own route table. When you associate a subnet to this client VPN endpoint, what we will do is we will automatically add the local route of that VPC, only the local route, not any of the learned routes, the local routes of that VPC to our route table. And basically, the route table looks like, in this case, your VPC is 10.1/16, so your route table will say, hey, your destination is 10.1/16, and the target is that VPC subnet that you associated. So at this point, you can actually establish VPN sessions, but you're not going to be able to access any resource. The reason is, remember the second wall I talked about. The first wall is authentication. You got through that. You're hitting the second wall, which is authorization. You've not yet configured any authorization rules. So right now, by default, when you create a client VPN endpoint, you don't have access to any network. Because it's an edge service, you have to come and explicitly open up every single network that you want your users to connect to. So the way you do this is you will configure an authorization rule, and the way it's going to look like, you're going to say, hey, for network 10.1/16, which AD group do I want to allow access? Now, if you're using mutual auth, you don't have AD groups, so then you can come and say 10.1/16, allow all. So at that point, you're going to allow access for all users. Right? So at this point, your end users can now access resources in that VPC. But one thing which I mentioned was, hey, you can actually access any resource, right? But here I'm saying you can only access resources in that VPC. So how do you open this up for other networks? If I can get this to work. There you go. All right. So let's first start with, let's say you have a VPC that's peered to your 10.1 VPC. It's a 172.31/16. That's the CIDR of your VPC, right? So you're going to do two things. The first thing you're going to do is you're going to add a route in the route table, which says for your 172.31/16, I'm going to go through this VPC subnet. And the second thing you're going to do is you're going to add a rule, an authorization rule, which says, now you're going to allow access for the network 172.31/16. Right? So you have to do these two steps. Add a route. So what the route is doing is you're creating the plumbing. Right? And once you add the rule, now you're actually providing the capability for traffic to flow through. So you need both. You need the plumbing as well as the firewall rule to allow traffic to flow through. Right? So this is here in this example which I talked about it's the 172.31, which is peer to your VPC. And this VPC could be in the same region or it could be in a different region. It doesn't matter. Right? So let's say if you want to go to on-prem, you're going via a VPN connection or a direct connect with the address of 198.1/16. What do you have to do? The same two things. You add a route and add a rule. So your route table is now going to have this third entry, which is 188.1/16. It's going to go via this VPC subnet. Right? And similarly, if you want to get to the internet, again, same two things. You add a route, 0/0, and you add a role. An interesting point that I want to talk about here is how does the authorization rules work? Right? So in this example, we've added 4 routes. Right? And so let's say I have an AD group 1 that wants to access my 10.1, and I have AD group 2 that wants to access 172.31. Right? But then I want to open up both the groups to the internet. So you're going to have 3 rules, a 10.1 that's allowing access to group 1, 172.31/16 allowing access to group 2, and a 0/0 allowing access to group 1 and group 2. Right? So now let's look at the happy case. A user from group 1 is trying to access 10.1. There's the route, so I have the plumbing, and then there's the authorization rule, so I'm going to let the traffic flow through. Now let's say I have a user from group 2 who's trying to access 10.1. Right? This is not my happy case. So I have the route, but when I try to do the rule match, because I have a very specific route here, which is I'm trying to access 10.1, I'm going to do a rule match on that specific network. So the 10.1 rule will actually take precedence over the 0/0 rule. So this is similar to routing when you have a very, like in typical routing, how it works is if I have a very specific route, I will do a match on that, and then if nothing meets, then I fall down to my default route. The way our rules work is also something similar. So by doing it this way, what ends up happening is when I hit that specific rule match for that network, like in this case, the 10.1/16, and I'm having somebody from group 2, for that 10.1/16 network, you're only allowing users from group 1, but this user is from group 2, so we're going to drop the traffic. We're not going to say, hey, this guy has a 0/0 rule that allows for group 1 and group 2. The 0/0 rule will not kick in. The specific network rule will kick in. So this way, we prevent users from, just because I have access to one network and you've opened up access to the internet, they're not going to be able to get access to other networks. So, and that's the reason why even when you're configuring this, the way we key this off is you have to specify for this network which groups have access to that network. Okay? Another question which will come up is like, hey, wait, how are you magically making this traffic go from this VPC to all these other peered VPCs or on-prem or the internet? The key to that secret sauce is the VPC subnet. The reason when you associate a VPC subnet to the client VPN endpoint, what I'm doing is in that subnet, I'm actually going to place an ENI, and I'm going to pick an IP address from that subnet that you associated with the client VPN endpoint. So now when the traffic flows out, it will actually look like it is coming from your VPC from that subnet that you associated with an IP address from that subnet. So that's the reason why now through this, now it's basically to look like the traffic is actually coming from this VPC. So the flip side of this is now if you're actually trying to do flow logs on your VPC, you're not going to see the client-sider's IP address because you're actually going to see the traffic it'll look like the traffic is coming from an ENI in that VPC subnet that you associated. So and the way we actually do this is we actually do an SNAT. From the client VPN endpoint onto your VPC subnet, we actually do an SNAT to that ENI's IP address. And that ENI's IP address is an IP address from the subnet that you associated with us. So once you've done this, so now your users can actually access resources in any location. They could be either in the VPC that you associated or in a peered VPC in the same region or a different region. Or it could be to AWS services via S3 endpoints or going via IGW or the internet or on-prem. So it's like you can get to anywhere so long as you have access to it from your VPC. So quick summary. So the steps that you're going to do, it's like there's 3 mandatory steps. The first step, you're creating your endpoint. The second step is you are enabling VPN connectivity for your end users. And the way you do that is by associating a subnet from a VPC to the endpoint. And the third step is you're actually enabling access to that VPC for your end users. And the way you do that is you configure authorization rules. So these are your 3 mandatory steps. You have the 4th optional step. If you want to start to open this up to more networks, right, then you go through these. You add a route for creating the plumbing, and then you add an authorization rule that's going to enable access for that particular network. Right? So these are your 4 steps for actually enabling the service. So kind of putting this together, just to summarize, so now with this client VPN, you're going to have 2 options for VPN solutions natively running on AWS. One is your site-to-site VPN. Like Tom mentioned, it's connecting 2 networks from your on-prem to your VPC. And your second option that will be launching soon is a client VPN endpoint, so where you can connect your user to AWS or to any other network that's connected to your network that you associated with the endpoint. Right? Thank you very much. And please do complete the survey. Right? Thank you.